A very implication for the z-score is to know the Chebyshev theory. So the theory is stated like this. At least 1 minus 1 over z squared of the item in any dataset will be within z standard deviation of the mean, where z is any value greater than 1. So you may feel a little bit confused. So let's keep going. So Chebyshev theory requires z larger than 1, but z need not to be integer. So what does that really telling us? Actually, it tells us before we get to do any calculation and how should we expect our data looks like. So we should have at least 75% of the data values must be within 2 standard deviation of the mean, and at least 89% of the data value must be within 3 standard deviation of the mean, and at least 94% of the data value must be within 4 standard deviation of the mean. So you must ask me, why should I know those kind of theories? Does that really matter? So let's keep going. So another more advanced application for Chebyshev theory is empirical rule. But there is one restriction on empirical rule. This rule only can be applied to the bell-shaped distribution, so such as what we just learned, the normal distribution. Since you've already learned the elementary statistics, you should know if we increase the sample size, any distribution will approach to the normal distribution. So the normal distribution is very, very popular distribution, and at the same time, the normal distribution is the bell-shaped distribution. So which means this empirical rule can be applied to any normal distribution. So the empirical rule can be used to determine the percentage of the data values that must be within the specified number of the standard deviation of the mean. Actually, this empirical rule is a more practical rule compared with the Chebyshev theory, but this rule is derived from the Chebyshev theory. So what does the empirical rule tell us, and how can we apply it? So for data having bell-shaped distribution, 68.26% of the value of the normal random variable are within 1 standard deviation of its mean, and 95.44% of the value of a normal random variable are within 2 standard deviation of its mean. 99.72% of the value of the normal random variable are within 3 standard deviation of its mean. So now, what can you figure out something from the 3 rules? So look at the last one. 99.72% of the value should be within 3 standard deviation of its mean. So if we are looking at the standard normal distribution, and you should know the mean equal to 0 and standard deviation equal to 1, and so you can see we only have 0.28% of the observation should outside of the 3 standard deviation of the mean. So if we have any observation is belonging to that 0.38%, what can you conclude? Do you think that can be the outliers? Think about it. Yes, you can think about those 8 if the observation fall in belonging to those 0.28%, and you can call it the outliers. So the last condition give us a hint on how to identify the outliers. So here is one more illustration how to look at the empirical rule. So you can find within the 1 standard deviation, we should have 68.62% of the observation. Within 2 standard deviation, we should have 95.44%, and with 3 standard deviation, we should have 99.72%. So we can see that the end of the distribution just a small portion. So if we have observation belonging to this 2 tiny area, we should count it as outliers. So here is the method we use to identify the outliers. So first, many of you already know what is outliers. So the outlier is an unusual small or unusual large value in a data set. The way we identify it is follow the empirical rule. So if we have the data value, and after we standardize it, and the z-score is less than -3 or greater than +3, this might be considered an outliers. So you must ask yourself why there is outliers in my data set. So it can be the possible three reasons. One, an incorrectly recorded data value. So sometimes if you hire somebody to collect the data, when they write down the data point, they may make some error. And the second possible reason to cause outlier is a data value that was incorrectly included in the data set. So maybe you are considering only Pennsylvania, the people collecting the data put one data set from the New York City. So obviously that's not the right way to include the data. And the third source to cause the outlier in the data set is a correctly recorded data value that belongs in the data set.